Hi, this time I'm going to talk through the Chemistry Unit 2 paper. That's the higher tier version for double award science, and that's the CA course. So I'm going to look at the specimen paper and some model answers. Question 1. Rusting is a common example of an oxidation reaction. Explain what's meant by the term oxidation. So what they're looking for there is the gain of oxygen or the loss of electrons or hydrogen. That's for 1 mark. And in terms of electrons, what is meant by the term reduction? So mentioning electrons in the answer then, reduction is the gain of electrons. So each of the following reactions can be classified as an oxidation or a reduction reaction. We have reaction 1 here is copper sulfate and magnesium, giving magnesium sulfate and copper. Reaction 2 is the Haber process, nitrogen and hydrogen giving you ammonia. And reaction 3 is iron oxide and carbon monoxide, giving you iron and carbon dioxide, so what's happening in the blast furnace. So, which substance is being oxidized in reaction 1? So the thing which is being oxidized is gaining oxygen, so that's magnesium. See here it's going from Mg to MgSO4. We can say that nitrogen, why can we say nitrogen is being reduced in reaction 2? So if we look at the nitrogen here, it's going from N2 to NH3, so it's gaining hydrogen, and then this is reduction. So the full answer there, the nitrogen is gaining hydrogen and gaining hydrogen is reduction. Which substance is being reduced in reaction 3? So, well, you should know straight away that that's the iron oxide. So you can either name it iron 3 oxide or Fe2O3 for the formula. But just to look here, the iron oxide is losing oxygen and becoming just iron. So reaction 3 is the reaction which occurs in the blast furnace during the extraction of iron from its ore. Name the ore that is usually used. Well, that is hematite, so 1 mark for that. Part D, the reaction of nitrogen and hydrogen, or reaction 2, is part of the Haber process for the production of ammonia. This reaction can also go in the opposite direction, with the ammonia breaking down to form nitrogen and hydrogen. What is the name given to reactions of this type? It's reversible. Don't be tempted just to write the little reversible arrows there. It has to be the word reversible. When the Haber process is set up in a closed vessel, eventually the forward and backward reactions occur at the same time. State what has been established at this point. So forward and backward reactions occurring at the same time is dynamic equilibrium. So both ammonia and nitrogen are important commercially. Give one use of nitrogen and explain why nitrogen is suitable for this. So it's used in food packaging. And the reason for that is it's unreactive. So things like, your Pringles tubes or other bags of crisps or coffee, things which you don't want to spoil and are quite delicate, can be packed in a protective atmosphere of nitrogen. And once the oxygen is removed and replaced with nitrogen, then none of the bad bacteria can grow that would spoil the food. Name an important product manufactured from ammonia. Well, fertilizers. You could also say explosives, I suppose, but fertilizers was the one on the mark scheme. Describe the test for ammonia, giving the observation made for a positive identification. So this is the same as the test for HCl. But just in reverse. So you dip a glass rod into concentrated hydrochloric acid and then put it into the gas, and all of that first bit gets you 1 mark. And the second mark is for saying that white fumes appear. So for hydrochloric acid, the test would be to dip a glass rod into the ammonia and put it into the gas, and if white fumes appear, then it's hydrochloric acid. So that's good knowing that for both. Question 2. A student investigated displacement reactions and recorded some observations in the table. So the observations and the reactions are given. Copper and silver nitrate solution, colourless solution which turned blue and solid formed. Iron and zinc nitrate, nothing. Silver and iron 2 nitrate, nothing. Zinc and copper 2 nitrate, you had a blue solution which turned colourless and a solid formed. and iron and copper 2 nitrate, blue solution turned colourless and a solid formed. So let me just change this. I realised you couldn't see through it there. Okay, so a solid is formed when copper reacts with silver nitrate. What colour would you expect the solid to be? So you've got copper and silver nitrate. Copper is more reactive, so it's going to displace the silver. So you'd expect the solid to be silver grey in colour. So why did the blue solution turn colourless when zinc powder reacted with copper 2 nitrate? That's because zinc nitrate is colourless. Yeah, you could talk about the zinc being more reactive and so on, but that doesn't actually answer the question. It's the reason it's colourless is because zinc nitrate has no colour. C then, using the information from the student's investigation, list the metals copper, iron, silver and zinc in order of reactivity from the most reactive to the least reactive. So looking at the reactions here, we have zinc. When it was in zinc nitrate, with the iron nothing happened, but it was able to displace the copper. So zinc is the most reactive. Iron also able to displace the copper, so more reactive than copper, but not as reactive as the zinc, as we saw in this reaction, because it couldn't displace, couldn't displace it there. So zinc, then iron, then copper, and bottom of the heap is silver, which is displaced by pretty much everything. So where that was marked, all four right, you got 2 marks. If you had 2 or 3 right, you only got 1. And if you had just 1 or none right, you got 0 marks. Number 3 is about electrolysis. Ionic compounds such as lithium chloride conduct electricity when molten or dissolved in water. Draw a labelled diagram of the assembled apparatus used to carry out the electrolysis of molten lithium chloride. So here it is. We have a tripod here, 1 mark for that. Pipe clay triangle on top of the tripod, another mark for that. Little crucible, you see on top of the pipe clay triangle, and then a power source and the electrodes. There's another mark there. And a mark for showing that you're heating it. So if you had any 4 of those things labelled, you would get your marks. Actually, it should be any 5 of those. It should be 5 of those. So if you had no labels, it was 0. I think actually it was if you had any 4 of them, and then the labels were your extra. So electrodes are made from graphite. Give one reason why it's suitable for this use. Either it's a good conductor, or it's inert, or high melting point. Any of those would do. Part B is about aluminium. So aluminium metal is extracted from pure molten aluminium oxide by electrolysis using the cell shown below. Describe the production of aluminium metal from pure aluminium oxide in an electrolytic cell. Then we have the anode here, you can see, which is at the top. The cathode is round the bottom. Then the aluminium oxide, which is in molten cryolite, is in the middle. And then a steel tank around the outside. So it says your answer should include the following information. So this is your tick list as you go through your answer. Make sure you hit each of these points. A reason for using electrolysis as the extraction method. The name of the ore from which the aluminium oxide has been obtained. Ionic equations for the reactors at the cathode and the anode, and then why the anodes must be replaced from time to time, including an equation. So the first point, why is electrolysis used as the extraction method? Well, it's because aluminium is very reactive, so electrolysis has to be used because the aluminium is too reactive for alternative extraction methods. So something like the blast furnace wouldn't work, and just your smelting for the less reactive metals like copper wouldn't be able to displace aluminium from its ore. And that takes us to the next point. The name of the ore is bauxite. And then ionic equations for the cathode and the anode. I put these slightly out of order, but the anode, you have the oxide ions, O2 minus, going to oxygen gas, O2, so it's 2O2 minus, gives you O2 and 4 electrons. And then at the cathode, we have the aluminium ions, Al3 plus 3 electrons, giving you aluminium metal. Why the anodes must be replaced from time to time, including an equation. So it's the anodes combine with the oxygen, so they burn away and then they must be replaced. And the equation for that is C plus O2, C for the graphite in the electrodes, and O2 for the oxygen gives you CO2. Now, if you had got 6 or 7 points here, that was 6 marks. 4 or 5 points would take you to 4 marks, and 2 to 3 points, 2 marks. If you only got one indicative point, one of those points, you didn't get any marks. Okay, number 4. Organic chemistry is the study of carbon compounds. For ease of classification, organic compounds are split into different homologous series. What do you understand by the term homologous series? So a homologous series differs, each member differs by a CH2 group. They have similar chemical properties and they show a gradation in physical properties. So all 3 of those for 3 marks. And crude oil is the world's main source of hydrocarbons. It's a mixture of many different hydrocarbons, and before they can be used, they must be separated by a process of fractional distillation. What is meant by the term hydrocarbon? So you need to say that it's a molecule containing carbon and hydrogen, and that gets you 1 mark, and then only is your second mark. And the second mark is dependent on the first in that case. So what that means when you're looking at a mark scheme, if you see that, is you can only get the second mark here if you give the correct answer for the first part. So what physical property of the hydrocarbons allows them to be separated by fractional distillation? So distillation, you know, is all about evaporation and then condensation. So it's their boiling points. And further processing of the separated hydrocarbons is needed to provide the actual molecules needed by the petrochemical industry. So butane and ethane are obtained by the cracking of hexane. Write a balanced symbol equation to represent the cracking of hexane, C6H14, to form butane and one other organic compound. And it actually tells you in the question what that is. It's ethane there. So you can work it out anyway, because you need to work out, you know, just how much you've got. So you've got your C6H14. There's no marks for it. It's given in the questions. Then butane, methane, bute. So 4 carbons, C4. And then it's an alkane. So CnH2n plus 2. 2 4s are 8 plus 2 is 10. So C4H10. 1 mark for that. I imagine you know the formula of butane anyway, as it's one of the examples or one of the ones that you have to know. You should know methane, ethane, propane and butane. And then the other product is ethane, which I'm quite sure you do know is C2H4. But again, it's an alkene, so CnH2n, so C2H4, and 1 mark for each of those. Butane, in common with other saturated hydrocarbons such as methane, that can be used as a fuel, and when they burn, heat is given out. The equation below shows the reaction when methane burns completely in oxygen. So if CH4 and 2O2 gives you CO2 and 2H2O. So this equation can be represented using the structural formulas below. And you see here they've been drawn out showing each of the bonds. So there's 4 of these carbon to hydrogen bonds in the methane, and then in oxygen molecules, 1 double bond between the oxygens, and then you can see the 2 carbon to oxygen double bonds in the carbon dioxide, and each water molecule has 2 oxygen to hydrogen bonds. So use the bond energies given in the table below to help you calculate the energy change expected for this reaction. So what we have to do first of all is work out the energy needed to break the bonds, and then the energy given out when the bonds are made. So looking at everything on this side, that's the bonds that we have to break. So we've got 4 of these carbon to hydrogen bonds, and then 2 of the oxygen to oxygen bonds. So it's a case of looking them up on the table. So 4 of the carbon to hydrogen bonds, 4 times 435. 2 of the oxygen double bonds, so 2 times 498. When you add all of that up, you get 2,736 kilojoules. Now, in the mark scheme, they didn't call for the units, but it's good practice to use them anyway. So on the other side, we've got 1 carbon dioxide molecule and 2 water molecules. So in the carbon dioxide, we have 2 of these carbon to oxygen double bonds, so 2 times 805. And then in the water, there are 2 molecules of water, so there are actually 4 of the oxygen to hydrogen bonds, so 4 times 464, and that gives a total of 3466 kilojoules. So the overall change then is the bonds broken, take away the bonds formed, so we have 2736 minus 3466, and that gives a total of minus 730 kilojoules. And of course, it's very, very important that you get the correct sign, because that tells us whether it's an endothermic or exothermic reaction. Sorry, the iPad's been very slow at saving these images today. So then this is the maximum amount of energy released when the Bunsen burner's air hole is open. Suggest why the amount of energy released is less when the air hole is closed. Well, that's just saying, basically, do you understand how combustion works? Which is, when it's complete, you're getting more energy. So if the air hole is closed, less oxygen is getting in. So combustion is incomplete, so less energy is given out when the new products form. Then draw a reaction profile diagram for the reaction when methane burns completely in oxygen. Indicate the activation energy on the diagram. So you'll remember here in the last question, it was negative, so that means it's exothermic. And when you're drawing this, you need to have the reaction pathway on the x-axis, the energy is on the y-axis, and then you show reactants and products. So having here the products lower than the reactants gave 1 mark. Having the axes labelled was 2 marks. Labelling reactants and products was another mark. And then labelling the activation energy here was another mark. Okay, and then just drawing the reaction profile as expected. So 5 marks for that in total. Next one is about polymerization. So it says chloroethane is an alkane. A large number of these alkene molecules, known as monomers, can join together in a long chain to form a widely used polymer, polyvinyl chloride, which is PVC, or polychloroethane. So what is this process known as? So you need to give both parts of this. It's addition polymerization. Give an equation for the production of PVC from an individual monomer of chloroethane. So here is the chloroethane. It's just ethane with one of the hydrogens substituted for a chlorine, and we're writing N in front of that, and then that gives you, and this is the monomer, basically just with the double bond opened out to give a single bond sticking out each side of the square brackets, and N here. So you can see that there was 1 mark for having N of the monomer with the double bond intact, then 1 mark for having the repeat unit shown, then for having the lines extended outside the brackets, and then the N repeating units was their final 4th mark. Next part, ethanol is found in the alcohol hand wash used for sterilisation purposes in hospitals and in alcoholic drinks. So the alcohol present in drinks like wine and beer is produced by fermentation. Explain the process of fermentation. So 3 marks for this. So you need to say 3 things. The first mark is for saying that there are enzymes in yeast, and that those enzymes convert the sugar, and they convert it to ethanol at around 35 degrees. And they would have accepted at a warm temperature instead of being specific with 35 degrees. So if a bottle of wine is left open to the air, the ethanol can oxidise, forming ethanoic acid. So ethanoic acid, in common with other carboxylic acids, is a weak acid. Explain what you understand by the term weak acid. So if it was a strong acid, you know what that would be, but weak acid, it's only partially ionised in solution. So strong acid would be fully ionised in solution. The main constituent of vinegar is ethanoic acid. An investigation into the reactions of ethanoic acid and salt formation was recorded in a lab book as follows. Test 1. Solid A was added to the ethanoic acid in a test tube. I saw bubbles and put a lighted splint into the test tube and heard a squeaky pop. Squeaky pop We know what that is. Identify the gas formed. Hydrogen, 1 mark. So classify solid A. Well, if you're putting a solid into an acid and you're getting hydrogen, it must be a metal. Test 2. I added solid B to ethanoic acid and saw bubbles. When I put the lighted splint into the test tube, it made the bubbles go out. Identify the gas formed. Well, the gases that you need to know about in these tests would be oxygen, carbon dioxide and hydrogen. Hydrogen we know is a squeaky pop. Oxygen relights a glowing splint. But if a splint goes out, it must mean that it's carbon dioxide. And then classify solid B. So if something is making carbon dioxide, it must be that it is a metal carbonate. And again, we're saving here, bear with it. I'm going to go on to test 3. Solid C was added to the ethanoic acid. No bubbles were seen. So classify solid C. Oh, here we go. So just to go back there, the gas formed was carbon dioxide and it was a metal carbonate. Just to say carbonate was sufficient. So then C was added, no bubbles were seen. Classify solid C. So anything from these 3, it could have been a metal hydroxide, a metal oxide, or an unreactive metal. And then it asks you to draw out the full structural formula of propanoic acid, showing all the bonds. So meth, eth, prop, 3 carbons, filling in hydrogens around these ones, and then the carboxylic acid group is the C double bond O, OH, and showing all the bonds. So don't write just OH run together here. It has to be every single thing separate and with bonds in between. Number 5 then, hydrogen peroxide decomposes slowly in sunlight to produce water and oxygen. Write a balanced equation for this reaction. So hydrogen peroxide is H2O2, water is H2O, oxygen is O2. To balance that we need 2 hydrogen peroxide and 2 water. 3 marks for this, and as usual, 1 mark for the left hand side, 1 mark for the right hand side, and 1 mark then for balancing. So this reaction requires a high activation energy and so is very slow. It can be speeded up by adding a black powder, MnO2, or manganese 4 oxide, which acts as a catalyst. What do you understand by the term activation energy? So you need to say the minimum energy needed for a reaction to occur, or the minimum energy required for a reaction to occur. You must have minimum in there. So explain as clearly as possible using the idea of activation energy how a catalyst in this reaction works. So a catalyst provides an alternative reaction pathway with a lower activation energy. 2 points, 2 marks. B, the curves below show the volume of carbon dioxide formed by reacting excess marble chips or calcium carbonate with dilute hydrochloric acid. So we have 4 curves here. We can see there's A, B is here, then we have C and D. So it says the curve labelled D is for the reaction of 50 cubic centimetres of 0.1 molar hydrochloric acid with excess marble chips. So state which curve would be obtained by reacting 100 cubic centimetres of 0.1 molar acid with excess marble chips. So the difference here is that the volume of the acid has changed. It's twice as much. So where D was very low down there, C, so this was D. So B is going at the same speed roughly as D, but given twice the volume of gas produced. You see the difference there on the graph. Then reacting 50 cubic centimetres of the hydrochloric acid with powdered marble chips. So you're looking at something which gives the same volume as D, but in a faster time. So that is C. And then finally 50 cubic centimetres of 0.2 molar acid. So we've got double the concentration of acid here, so that means it must be A. So we're getting twice the volume of the gas produced. Now, the reaction of the marble chips with hydrochloric acid is described by the equation that CaCO3 and 2HCl gives CaCl2 plus CO2 plus H2O. If the desired product is the calcium chloride CaCl2, calculate the atom economy for this reaction. So first mark there's for working out the formula mass of the desired product, which is the calcium chloride CaCl2. So calcium's 40 and each chlorine is 35.5, so you add those together, you get 111. Then the formula mass of the reactants has to be calculated. So that's CaCl2, which is 111. The carbon dioxide, which is 1 carbon, is 12, and 2 oxygens is 2 16s, which is 32. So 44 for the carbon dioxide, and then 18 for the water. So that the total there is 173. And then the atom economy is the mass of the desired products divided by the total mass of the reactants, which when you do 111 divided by 173, you get 64.2%. So 3 marks there. 1 for the formula mass of the product, 1 for the formula mass of the reactants, and the third mark then for the atom economy. Number 6, since 2003, NASA has been involved with the exploration of the planet Mars. They're interested in finding out about the planet, in part looking for evidence that Mars could have supported life. Unlike Earth, Mars is not hospitable as it does not have an atmosphere like ours. So when you get a blurb like that, you very often get a clue in it as to what it's going to be. This is about atmosphere. So Earth's atmosphere contains a mixture of gases, including the oxygen we need to live. Along with oxygen, other gases are present as shown in the table below. Complete the table by entering the percentages of nitrogen and oxygen present in the Earth's atmosphere. So nitrogen, 78, and oxygen, 21. And then you see the other gases that are given there: carbon dioxide, approximately 0.3 to 0.4, argon about 1, very small quantities of noble gases, and variable quantities of water vapour. So the 2 marks were for those answers there. Now, human activity can cause damage to the atmosphere by releasing pollutants. Name a pollutant associated with the burning of fossil fuels and describe any adverse effects associated with this pollutant. So you're getting 1 mark for the name and 1 mark for the adverse effect. And I've given 4 here, but you only need 1 of these. So if you said carbon dioxide, you're talking then about the adverse effect is the climate change. Because of the greenhouse effect, you could have mentioned sea levels rising, flooding, and so on. With sulfur dioxide as the pollutant, you'll be talking about acid rain, and the effect then of that is damage to buildings, vegetation, killing fish as the acidity levels in lakes rise, and so on. Carbon monoxide, the adverse effect of that is that it is a toxic gas, and then soot or carbon can cause damage to your lungs. So any 2 of those, any 1 of those, and the pollutant and the adverse effect, both needed. And the final question, as an alternative to fossil fuels, hydrogen is often suggested as the fuel of the future. Explain why hydrogen is described as a clean fuel. Well, hydrogen, when it burns, reacts with oxygen to give you water, H2O. So the product of combustion is water vapour, which is not seen as a